Okay. Now see this question. First, we'll read out all the things and try to underline those points which are important for you to note it down. Water treatment plant treats 25 mLD. So this is the discharge which is mentioned to you. Note it down. With a natural alkalinity, that is the amount of alkalinity which is present already. So alkalinity present is given to you 4 milligram per liter as a CaCO3. It is estimated that during coagulation of water, 450 kg per day of calcium carbonate, calcium bicarbonate. So in terms of calcium bicarbonate, they have given you. So this point you need to note it down. So 450 kg per day of calcium bicarbonate is required on the alum dose. Consider the atomic weight is mentioned to you. Quantity of pure quicklime CaO required for this process per day, rounded off to the 2 decimal places. Okay. Easily we can solve this question. First thing first, the total amount of it is estimated that during coagulation of water, 450 kg per day of calcium bicarbonate is required based on the alum dose. So alkalinity required, how much we have? Alkalinity required, how much we have? 450 into 450, that is the alkalinity required. It is estimated that during coagulation of the water, 450 kg per day of calcium bicarbonate is required based on the alum dose. So 450, this value is in calcium bicarbonate part with respect to calcium bicarbonate. You need to change it you have to make it with respect to calcium carbonate. Okay. So in that case, what we need to do? We need to divide this value with the equivalent weight of calcium bicarbonate and then multiply. Why we are dividing it? Because we want to convert this value in the gram equivalence part. Then again we are multiplying with the equivalent weight of calcium carbonate, because with respect to that only we want to represent our value. So calcium carbonate equivalent mass, if you calculate it, molecular mass will be how much? 40. Calcium is 40, carbon 12, 52, 52 plus 48, it will be 100. The valency is 2, so the equivalent mass is 50. I hope from like how we have written this 50 part, I think it's crystal clear to all of you. Okay, so or if you want, you can write it also. Equivalent weight of calcium carbonate divided by equivalent weight of calcium bicarbonate. Okay, so this we got 450 into equivalent weight, we have 50 divided by calcium bicarbonate weight we have that we need to calculate it actually. This will be 61. So 40 plus 61 into 2. Okay, so this will be 122, I think, plus 40, it will be 162 divided by 2, because valence is 2 here only. So 81, I think. So 81 will be the value. This part I'm erasing it. Okay. So after calculation, how much you are getting? So according to my calculation, I'm getting around 277.78. Okay. One issue in this question, I will say, technically, because they have not directly mentioned it, that this is the actually alkalinity which is required, or it is the alkalinity which is required minus alkalinity which is present. That means the 450 kg per day, this is the actual alkalinity required, or they have subtracted the natural alkalinity also which is already present in the water. That is something which is not mentioned in this question. That leads to some controversy. I will say that leads to some confusion, not controversy. That leads to some confusion, but we'll follow the general procedure. Okay. So 277.78 kg per day, that is what alkalinity required, which we got. Okay. Next, To find out lime dose, we know the lime we are requiring it only to only for the alkali deficient part. So the alkali deficiency we need to calculate it. So let us say this is alkali required, which we have calculated, minus alkali which is present. So required is 277.78 according to my calculation. Minus, see, we have 4 milligram per liter which is already present, but that is in milligram per liter. We want in a kg per day. So you know how to convert it. Basically multiply with the discharge in MLD. So after this we got 177 maybe. 177 kg per day. And for that, if you want to find out the amount of quicklime, that is easy to find it out. Amount of quicklime, basic small formula which I have given in class also, that is 56 divided by 100 into alkali deficiency, that is 177.78. Now it's just a matter of calculation. Please check whether they want this value in kg. Okay, they want this value in kg required for the process per day. So they want this value in kg per day. They want this value up to 2 decimal places. So first calculated how much we are getting. 56 divided by 100 into 170. So roughly 99.55. According to my calculation, we are getting 99.55 kg per day. That is the amount of quicklime which is required. Amount of quicklime which is required. Okay. I hope it is crystal clear to all of you. I hope it is crystal clear to all of you.